share my screen and we'll get started here.
Okay.
A point is chosen randomly on PS.
Mhm.
Okay, so PS goes from all the way from the left to the right. Okay, and they want the probability that the point is on RS. So in short, you need to figure out how long RS is divided by how long PS is.
So that'd be 5/2.
Well, you just said 5/2, but the PS goes all the way.
Oh, PS. Okay, so that's 2 plus 6 plus 5, so that's 13. 13, so 5/13.
5/13, perfect. Okay, so in probability, the thing that goes on top, that's what you care about, or that's the success. On the bottom is all the possibilities.
I see.
Okay, so I'm gonna give you one like it, and I keep forgetting that I should not snip in the answers because they can be distracting here for you.
So like am I able to reduce if both top and
Yes,
bottom numbers are even? Okay.
or odd, or lots of things.
Yeah.
So give this one a try. It's just like the last one. Actually, I take that back. It does say not on A, B, or CD. So A, B, and CD are here. So it's the 10 that you care about.
So it'd be 10 and then 8/18. But then I can reduce that.
No,
So
no, no. What? No. AD, AD, AD.
oh, 28.
Okay, so what does this reduce to?
That reduces to 5/14.
Okay, good. All right, so no more questions like that. They let's actually, I'm sorry. There is one more like that. So we'll do that next. Okay, so try to work this one all the way through. Remember, if it says K to N, KN, that means that it's the whole way across. The whole way across, right? KN is all the way across.
7/18. 7/18.
Okay, how did you come up with 7 on top?
So it wanted the so when it said they're KN, I added everything from K all the way to N. So I get 18. And then it said there is on KL or MN. So oh dang it. I messed that up. Then that's 11.
Okay, so or means add. Does that
Yeah.
make sense?
Yes.
Okay. I'm just looking at the next question here. Okay, so let's take a look at this next question. This one you have to read to be able to answer. A washing machine has the following cycle: soak for 15, wash for 30, and rinse for 10 minutes. Okay, so what's the total time that it's doing stuff?
That is 55 minutes.
Right, 15 plus 30 plus 10. Okay. What is the probability that the cycle will be in the rinse phase? So we only care about rinse. Rinse is success. So how many minutes is it spending in rinse?
10.
So what is 10 over 55? When you actually this time just go to your
2/11.
It is 2/11, but what is it when you put it in a calculator, please?
Oh. 0.18.
0.18, yes. Okay. So I'm just looking at the next two questions. Okay, these are these questions are good, but they are a little bit out of scope for like a student first learning this. But we're going to be okay here. A train arrives at a station, waits 3.5 minutes before starting. So here's time 0,
Mhm.
and it waits 3.5 minutes.
Yes.
Okay. Another train arrives at the station 16 minutes later. So how many? So this is 16 here. Okay. Okay.
So
But
that's
then
12.5.
what is 12.5?
Oh, you're s- so like that's time difference because
Well, that's true, but it says it starts here, it waits 3.5 minutes, and then you wait another 16 minutes. Okay, but it says repeating the cycle. So the cycle refers to this 3.5 minutes.
I see.
Okay, so maybe I mislabeled this, but it's 3.5 minutes, then the train goes away. Like imagine you're standing there. That's the perspective here. You're
Ah,
standing there and you're like, oh, a train arrives and it waited 3.5 minutes, it's gone. Then I wait another 16 minutes.
that's
Okay.
20. That's altogether that's 23 minutes.
Okay, so over 23. And we want the probability that a train will not be at the station. So there's a train here, and there's a train here, and there's no train here.
So that's 16.
Okay, very good. So put that into your calculator and tell me what you come up with, please.
0.69.
16 divided by 23
Mhm.
is 0.69.
Mhm.
Interesting. Huh. Did you add these up correctly? You did. Really interesting. So that none of the answers that we
Well, what are the answers? Because there's stuff
so
after that, like 5 and
so I think it's just this. I think it's excluding this part. So I think it's 16 over 19.5.
okay. So let me put that in. 0.82.
Okay. I think that's what it is. I was expecting questions more like marbles in a jar, but they're not giving you that. So can't do that. All right. So a stoplight has the following cycle: green for 50 seconds, then yellow, and then red. Okay. Um, so, okay, so 50 seconds of green. Now you're driving now, you know this.
Mhm.
If it's green, do you wait at the light?
No, you keep going,
Keep going. And if it's yellow, you generally keep going.
but
But
you want
if
to slow
it's,
down. But
and so for 62 seconds, um,
you stop.
you stop. Okay. Um, so if you wait more than 4 seconds, I think what they're trying to say is that if it's yellow, this is really odd. So let's just assume this is right. The wait more than 4 seconds means it's 62 out of 50 plus 4 plus 62. So could you get that number for us, please?
Sure. 116. 62 over 116.
Okay, so this is the probability. Get this as a decimal for me. This is the probability that you're going to wait more than 4 seconds.
0.53.
0.53. And then if you multiply that by 50, I'll bet you get about 27.
26.72.
Yeah. All right. So interestingly, of course, that one isn't correct.
It says there predict how many, so you arrive at the light 50 times and then you predict how many times you'll have to stop and wait more than 4 seconds. So,
So
okay.
sometimes these questions are written in a way where something that's obvious to the person writing it is not obvious to us, and that's where we've got to.
Do you have to add 62 to 4?
I couldn't. Yeah, but maybe. let's not worry about it. Like, this is fine. We'll just move on to the question. Oh, this is interesting. So this will be related to maybe something that you're going to do later today. This is a spinner thing. So let me grab this here. So in a circle, I don't know if we've talked about this. In a circle, there's 360 degrees in a
Yes.
circle. So there's an unknown one here. I don't know if we need it, but we could figure it out. Would you agree with that?
Yeah.
Okay, so let's use the spinner to identify the probability to the nearest 100 of the pointer landing in a non-shaded area. So the non-shaded area is these over here.
Mhm.
Okay, so we do need X. Okay, so go ahead and add up these three numbers. Should be like 296.
Yep.
Subtract 296 from both sides, and you get 64. X equals 64. So now we want the non-shaded area.
Mhm.
So the non-shaded area is X, which is 64,
Mhm.
plus 172 over the whole, which is 360.
Yeah.
Did you follow how we did that? We found the non-shaded.
Mhm.
So give me that as a final answer, please.
In decimal,
Yes.
0.65.
Try one more time. What's the decimal? 0.6.
5555555.
Okay, so if you're going to two decimal places and the third decimal is a 5,
It's gonna be 0.7.
what does this one go up to? And
Oh,
this is a
6.
5. So it's 0.66. Now here's why you should care, because what if someday someone says, I'll give you 66%, and then they end up only giving you 0.655%? Well, they're shorting you a little bit. And if it's
Yes.
let's just say it's $1 million transaction, then
I see.
all right. Okay, so the next question here you can actually do on your own here. It's the same question that we just did. It's asking about the non-shaded region, but you don't have to find the missing one. So see if you can do this on your own, please.
Okay. Okay, I get 120.4 as my final answer.
What do you get?
120.4.
Well, how can that be, Christopher? What is the number that goes on the bottom?
It would be the shaded area. So that would be 60 plus 50.
No. What goes on the bottom? The total. The total goes on the bottom. What's the total area? What's the total of all of this?
Oh, I see. Then
What did I say in the first part? What are the degrees in a circle always at up to?
360,
Okay, so what do you care about? The non-shaded. What's the non-shaded?
200.
That's right. So try again. Give this to me as a decimal, please.
Okay, get 0.56.
Okay. Always check your rounding, because I don't want to have another.
I did. It's 0.555, but since it's asking for the nearest 100, I have to do 0.56.
Okay, let's look at the next one here. Oh, same thing. This is actually like the first one, where you do have to find that missing area. So the steps here are to first find X.
So we know it's 360.
Did you come up with the value of X?
Yes,
What is X?
93.
Okay. So we want the non-shaded again. So that's 93 plus 122.
Okay, I get it. Okay, I get 0.6.
Okay. Very good. So believe it or not, the next question is just like this. Oh boy. Well, you're going to be an expert at this. All right. So give this one a try, please.
Okay.
You're going to have to find X again.
Okay, my final answer is 0.69.
All right. Let me take a look here. All right. Well, that is an option. So we're going to go with it. And you're doing so well. Guess what you get to do?
I'm
Oh
not
man,
sure.
another one just like it. There's 6 questions exactly the same in this lesson.
Oh,
So it's this and then one more.
I see.
This again, you got to find X, and then you got to find the, and then you find the probability.
Okay, I get 0.47.
0.47, you said?
Mm-hmm.
Okay. All right, now the last one is a small variation on it. This time they want the shaded area, not the unshaded area. So let me snip it in here. Okay, so they want the shaded area. So notice you do not need to find X because you don't, it doesn't matter what this one over on the right is. This area over
Yeah.
here on the right. You just wanted a 90 plus 30 over 360 because you want the shaded area this time.
Point 0.33.
Yes, good catch there. All right, so the next lesson in your class here is another lesson in probability. I don't know what to expect after that, but we'll pick up there next time. So thanks so much for scheduling, and I'll see you then.
All right.
Bye now.
Bye.